Hello students, today we shall see the part 2 video of chemical bonding. In today's class, we will see what is covalent bond and what are non-polar and polar covalent compounds and what are the conditions for the formation of a covalent bond and the structure of covalent molecules. Okay, what is covalent bond? Covalent bond is also called to be as molecular bond. The definition: the chemical bond that is formed between two combining atoms by mutual sharing of one or more pairs of electrons is called a covalent bond, and the compound formed due to this bond is called a covalent compound. So, already we have learnt about electrovalent bond, which is loss or gain of electrons. The bond formed is due to loss or gain of electrons. And this covalent bond is the bonding formed by mutual sharing of electrons. So, when I say the mutual sharing of electrons, so when two atoms are taking part in this bond formation, one atom is giving equal amount to the other atom, equal amount of electrons to the other atom, and the other atom also sharing the same equal amount of electrons to the first one. So that is called the mutual sharing of one or more pairs. So what is one or more pair means here? If one electrons, the first atom is give one electrons means the other atom also give one electron. So they are sharing mutually one, either one or two or three, like that. So the chemical bond that is formed between two combining atoms by mutual sharing of one or more pairs of electrons is called covalent bond. And the compound formed due to this bond is called a covalent compound. So any compound is formed by means of this covalent bond is called as covalent compound. The molecule formed due to the sharing of electrons is called covalent molecules. So the molecules formed due to the sharing of electrons is called as covalent molecules. Not only covalent compound, it is if it is a molecule, then we can say it is a covalent molecule. If it is a compound, we can say it is a covalent compound. So see, the atoms of non-metals usually have 5, 6 or 7 electrons in their outermost shells do not favor the loss of its electron due to the energy consideration, and thus transfer of electron is not possible. Therefore, this atom can complete its octet only by mutual sharing one or more pair of electrons. Each atom contributes equal number of electrons. So, I already told you each atoms when taking part in the bond formation, they are contribute equal number of electrons. Equal number means either 1 or 2 or 3. So generally the non-metals which are having usually 5 or 6 or 7 electrons in the outermost shell do not favor the loss of electrons. So they usually tends to gain electrons to attain the stability. So they won't lose electrons for stability. So since they won't lose electron for stability, they are only gaining electrons. When two similar kind of non-metals or different non-metals, when they are combining, they are mutually sharing the electrons. So transfer of electrons is not possible between the non-metals. So hence the transfer of electrons is not possible. So examples we can see HCl, hydrogen chloride. So hydrogen and chlorine. So both sharing one electrons among themselves. This is an example of covalent compound. And Cl2, chlorine molecule. So two chlorine atoms are present. Each share their one electrons among themselves. So this is an example of covalent molecule. So the covalent bond are of three types. So how many types are there? Covalent bonds are of three types. So we can name it as a single covalent bond, double covalent bond and triple covalent bond. So what is single covalent bond refers? With the bonds, the number of electrons shared between these two atoms are only one electrons, then they are called a single covalent bond. Here we have example. Look at this, a hydrogen. They are sharing only one electrons among themselves. Chlorine, they are sharing one electrons among themselves. And in water, so between this hydrogen and oxygen, one electrons is sharing. Between this oxygen to the other of hydrogen, they are sharing one electrons. So these three are examples for single covalent bond. Similarly, this CO2 carbon dioxide. So the example for double covalent bond. So between this oxygen and carbon, two electrons are shared. Between this carbon and oxygen, two electrons are shared. Similarly for triple covalent bond, nitrogen molecule. So between these nitrogens, three electrons are sharing. So they are triple covalent bond. Some compounds which may be taken example for more than one type of bond. For example, ethane. If you take ethane C2H2, how the structure would be means two carbon atom have been paired with triple bond, and each carbon is linked with one hydrogen, that is single bond. Other carbon is linked with the other hydrogen, that is single bond. So ethane molecule has one triple covalent bond and two single covalent bond. Okay. So what is covalency? So the covalency of an atom is the number of its electron taking part in the formation of shared pair of electrons, shared pairs. Thus, the covalency of hydrogen is 1. So hydrogen sharing 1 electrons among themselves. Oxygen sharing 2 electrons among themselves. Nitrogen is sharing 3 electrons. And carbon is 4. Non-polar and polar covalent compounds. So far we have learnt what is the definition of covalent compounds and the examples in each cases of the three types. Now we will see the non-polar and polar covalent compounds. So what is non-polar and polar? How to differentiate the compound is non-polar covalent compound or polar covalent compound? Let's see. Covalent compounds are non-polar when shared pair of electrons are equally distributed between the two atoms. The molecule is symmetrical and electrically neutral. You should note that the molecule is symmetrical and electrically neutral. So when I can say that compound is a non-polar, which means the shared pair of electrons are equally distributed, which means they are sharing one pair of electrons or two pair of electrons, but the electrons were equally distributed between the two atoms. They should have equal energy among themselves. So electrically neutral means equal number of positive charge and negative charge should be present in the atoms. So equally electrically neutral. Symmetrical means symmetrical. If we cut structure, it would be look like a equal of, that is a symmetrical structure. If we have equal symmetrical, then equal amount of energy is transferred, or they are sharing among the atoms. Hence there comes under non-polar covalent compounds. Okay, the covalent bond formed between similar atoms like hydrogen, chlorine, oxygen. So these are all example of covalent bond. Okay, but they occurs when with the similar atoms like two hydrogen atom, two chlorine atom, two oxygen atom. So these are considered to be as a perfectly polar bond because the shared pair of electrons attracts equally by the nuclei. So the nuclear charge would be same for two hydrogen and two chlorine and two oxygen. So the attraction between the one atom and another atom would be equal, and there is no excess of charges among themselves, and because of that they are perfectly non-polar because of the electrons attracts equally by the nuclei. It means a little or no electronegativity difference, zero electronegativity difference. No electronegativity difference means zero electronegativity differences of the two types of charges. This is one category in covalent bond with a non-polar. The covalent bond are formed between dissimilar atoms like CH4. Here these carbon and hydrogen are not same. Carbon is different, hydrogen is different. Carbon is different, chlorine is different. Carbon tetrachloride CCl4 can be non-polar if their electronegativity difference is little and the structure permits the shared pair of electrons to attract equally. Which means in this structure, if you noted that CH4, C is present at the center, on all the four sides hydrogen atoms are present. That is the structure, right? So at the center carbon is present, equal distance hydrogen have been there, and their force of attraction, each hydrogen atoms have the force, good force, I mean equal force of attractions from the carbon, from the center. So they have electronegativity differences little. Okay, and the structure permits because this can be taken as a symmetrical structure if we cut. of symmetrical structures can be obtained. So the structure permits the shared pair of electrons to attract equally. The linked atoms, thus molecule become symmetrical. So because of the reason. Also you can see that the electronegativity value, carbon is 2.5, hydrogen is 2.1. Difference is less than 1, which is 0.4. So little electronegativity differences, which means little electronegativity differences. So they are also non-polar. Okay. So you can see this picture, the electronegativity differences between ionic bond, that is electrovalent bond 1.7 or more. Generally for polar covalent compounds less than 1.7. For non-polar it is 0 to 0.4. So now we have seen about non-polar. The next one is polar covalent compound. So before enter into that, we'll see these compounds do not ionize in water due to lack of charge separation. So as we know that they are not the charge separation does not occur and does not ionize. I mean to say covalent compound are not ionized. Electrovalent compound are ionized because they have a more electronegativity differences and charge separation is more possible. Hence, they ionize in water. That's why they are called as ionic compound. But covalent compound is not ionized easily due to lack of charge separation. Okay. Then the covalent compound are said to be polar when shared pair of electrons are not at equal distance between the atoms. So in this case, when the compound is said to be polar covalent compound only when their distance, electron distance are not at equal distance. So this result in the development of fractional positive and negative charges on them. They ionize in water. For example, hydrogen chloride. So if you take a hydrogen chloride, hydrogen and chlorine, and the electronegativity value of hydrogen and chlorine is which means see this hydrogen electronegativity value is 2.1 and for chlorine is 3.3, that is so which is almost 1. The electronegativity value is almost 1. So they can said to be as a polar. Examples here given: polar covalent hydrogen. So you can see this, they are producing a partial charges, excess charges over it, and then they are said to be as a polar covalent compound. And here I have given an example of water for polar covalent compound. Okay, and you can see this bonding between hydrogen and oxygen, bonding between hydrogen and oxygen here, which are producing the slight positive charge over the bonding that results in the formation of polar. Okay, and do you know how this polar, or how can we say that compound is non-polar or polar or ionic compound? Let's see here. The process by which covalent compounds are converted into ions is called ionizations. As we all know well this, the process by which covalent compounds are converted into ions is called ionization. So when covalent compounds are ionized, then it is said to be as ionization. So a polar covalent molecules has both slight positive and slight negative poles. I mean the charges. So because of this, it is also known to be as a dipole molecule. Very important. It is also known to be as dipole molecule. Which one? A polar covalent molecule. Because they produce a slight positive and slight negative charges. That is slight negative and slight positive poles. So they are said to be as dipole molecule. And the bond formed between two atoms. Okay, any bond formed between two atoms with the same electronegativity value, it is non-polar. Slightly different electronegativity, it is a polar. Much electronegativity is ionic. Okay, then conditions for the formation of covalent bond. So here we are listing 5 important conditions. The first one is both atoms should have 4 or more electrons in their outermost shell. That is, they must be non-metal. Exception cases are given: hydrogen, beryllium, boron and aluminium. So because they should have 4 or more electrons in their outermost shell. And both the atoms should have high electronegativity value. Both the atoms should have high electron affinity. Both the atoms should have high ionization energy. All this must be high. Keep in mind, high electronegativity, high electron affinity and high ionization energy. Then the electronegativity difference between the combining atoms should be either 0 or negligible. Okay, these are the important conditions for the formation of a covalent bond. Okay, so here hydrogen can combine with all non-metals of group 6A to 7A, sorry 4A to 7A with the help of covalent bonds. In this slide, you can see this group 1, group 2, group wise from group 1 to 7, and with their chlorides, metal chlorides, sodium chloride, magnesium chloride, aluminum chloride, silicon chloride, phosphorus pentachlorides. So all these chlorides are given. If it bonding with the chlorine, what is the type of bonding it produces? That is what we are given. For group 1, it forms ionic bond. For group 2, ionic bond. So ionic bond is nothing but the electrovalent bond, which means they can ionize easily because of more electronegativity differences value. But if you are moving to right, they are partially ionic and partially covalent. Then covalent in the solid liquid state and covalent liquid state. So the states are moved, bonding are moved from ionic to covalent. So in its react with the oxides, sodium oxide, magnesium oxide, what is the bonding? So ionic to covalent, you can see this. So across the period, the electrovalent character of chlorides, oxides, etc. are decreases. So electrovalent means the ionic bond. So the ionic character has decreases on moving from left to right across the period. Okay. Then let's see some structures, dot structures of covalent molecules. The first one, hydrogen molecule. Two hydrogen atoms are having, each having only one electrons in the outer shells, and they are combined with each other. Once they are combined, their atoms are being shared by each other hydrogen atom. So once they shared, there is a formation of single covalent bond. So the electronic configuration of hydrogen is 1. Nearest noble gas is helium. So after the combination has occurred, the hydrogen has attained the nearest noble gas configuration, that is helium. So this hydrogen is 2 and this hydrogen is 2. So they attain the nearest noble gas helium configuration. Similarly, the next example, second one is chlorine molecule. So each chlorine have a 7 electrons in the outer shells in the dot structures, chlorine molecules. So after combining, they are equally sharing 1 electrons among themselves, and thus results in the formation of single covalent bond. Okay, so before before combining, the configuration of chlorine is 2, 8, 7. After transfer, after sharing the electrons, it attains the nearest noble gas configuration, that is 2, 8, 8. Similarly, the third example, nitrogen molecule, that is N2. Nitrogen is 5 in the outer shell and each sharing 3 electrons. Because of sharing 3 electrons among themselves, it is said to be a triple covalent bond. So before transferring, it is 2, 5 the configuration. After transferring, after combining, it becomes 2, 8. That is the nearest noble gas configuration. Similarly, we are given for the water molecule, the fourth example. So before combining, how it would be, and after combining, hydrogen attain the configuration of helium and oxygen attain the configuration of neon. So 2 and 2, 8. And for ammonia molecule NH3, hydrogen before 2, 8 before combining, and after combining it becomes 2, 8, that is a neon's configuration. Hydrogen attain the helium's configuration. And other example, carbon tetrachloride. So in carbon tetrachloride, first carbon have 2, 4 configuration. After it's sharing the electrons with the other chlorine, it forms 2, 8. That is the configuration of neon. Similarly, chlorine before 2, 8, 7. After attaining the stability or combining, it have the combination of 2, 8, 8. 2, 8, 8 is argon. Okay, and after combining, you should have this like of structures. Before combining, you should mention this plus sign. Once it combines, no need to mention the plus sign. Instead of that, the bonding shall be arranged in such a way each should complete 8 electrons in the outer. Or you can also mention by either it is single bond or double bond or triple bond. In this case, ammonia 3 bonds are there between hydrogen and hydrogen, and one lone pair of electrons are present that not taking part in the reaction. And the last one is methane molecule, that is CH4. Here carbon 2 comma 4 and attain the nearest noble gas configuration after combining 2 comma 8. Hydrogen after attaining become 2, that is a helium gas configuration. So before combining we shall write like this with the plus sign. After it combines we shall remove the plus sign and make arrangement such a way each attain the nearest noble gas configuration, either helium or neon. For hydrogen it is helium, for carbon it is neon. Okay, thank you students.